Welcome to Toro NSN's Training in 10, the innovative, self-paced training module that allows you to get trained and to get going. Today's topic is how runtimes are created in SitePro using evapotranspiration. While this module is focused on SitePro versions 2.0 and above, the principles you'll see here apply to most previous versions of the software. This training module will cover topics including an explanation of precipitation rate, or what's also known as application rate, how SitePro calculates precipitation rate, how you can override this automated calculation and manually enter a precipitation rate, this precipitation rate and how it works with demand ET and the benefit of balanced runtimes, and other training in 10 options designed to help you become a better manager of your Toro SitePro system. Precipitation rate is the rate, which is expressed in inches an hour, that water is applied to an area or a field. In SitePro, this rate is measured independently for each station in the control system. Navigate to the control system station screen from the Setup menu, and then maximize the screen so that you can see more data at once. Using the scroll bar on the bottom, scroll to the right so that you can see information beginning with the nozzle flow column all the way through to the precipitation rate column. Here is where you can see the information that pertains to the station's precipitation rate, and it's calculated from information in this area. This is the precipitation rate for this particular station. To accurately calculate this rate, SitePro uses the following information: the nozzle flow, or how much water is being put down, the arc of the sprinkler, or the area in which the water is being placed, the pattern in which the heads are placed in the field, and finally, the head and the row spacing that these heads are placed. Now, the area definition and how much water is being placed there is somewhat self-explanatory. So let's focus on the pattern and spacing. Irrigation heads are designed and installed in specific patterns in order to maximize their coverage and enhance their application of water. There are essentially 3 different ways that heads can be designed and installed, the first of which is a rectangular or square pattern. The next way would be to triangulate them, which is like designing them in a square pattern, but the adjacent row is being offset here to create a triangular pattern. Lastly, you have stations where there's no opposing row, but just a single line of irrigation heads. SitePro refers to this as being an inline design. Spacing of heads is done in an attempt to maximize the sprinkler's application and to provide 100% coverage. In other words, the throw of one sprinkler head extends to all of the adjacent heads. For rectangular or square spacing, this is relatively simple. If the heads are spaced at 65 feet, then the next row is installed at this same 65-foot interval. For triangular spacing, it's a bit more in depth. With a 65-foot head spacing, the row cannot be placed at 65 feet as well, because this would create a head-to-head distance that is greater than the head spacing, and the goal of 100% coverage would be lost. So there's a formula that's used when designing triangular coverage that squeezes the row so that the row spacing is consistent with the head spacing, thus providing 100% coverage. Because there's no opposing row or rows to take into account for inline patterns, SitePro automatically calculates distance based on the throw of the chosen sprinkler. Pattern and spacing are 2 very important elements of determining precipitation rate. They help identify a surface area that irrigation is being applied, and this area is a fundamental element in formulating a precipitation rate for that station. With SitePro, you can also manually put these values in. You can have your course audited by an Irrigation Association certified golf course auditor, or you can measure the application rates yourself and then manually enter those new rates by simply clicking on the cell and typing in a new value. Like any other cell in the control system, when you manually override a calculated value, this new value will be blue. This blue does not mean that it's wrong. It's only an indication that you've manually entered a value rather than having it calculated for you by SitePro. So now you see how you can manually enter this value, or how SitePro calculates the precipitation rate based on different elements in the control system. But how does this precipitation rate interact with an ET rate to generate a runtime in SitePro? SitePro uses a very simple formula that takes the station precipitation rate, which is measured in inches an hour, and divides it by 60 to get a rate that's measured in inches a minute. That new value is then divided into the amount of application that you would like to apply, which is also known as demand ET. This gives you a value that equals the total runtime for that station. Let's look at an example. If a station applies 49/100ths of an inch every hour, divide it by 60, and you can see that the inches per minute application is 8/1000ths of an inch. 8/1000ths of an inch divided into the desired ET of 14/100ths of an inch equals a 17.5 minute runtime. For users of something other than Network 8000 or VP, you do not have the ability to calculate runtimes in minutes, so your system will round down and change to a 17-minute runtime. In this example here, we have 5 different heads, all on the same rough program, with some of these heads having different application rates due to their differing arc settings. If we were to use a default runtime on this program, we would then have to go back and manually adjust the runtimes on different stations so that the different arcs were addressed and water could be applied evenly. However, if we use evapotranspiration to create a runtime for this program, the application or precipitation rate for each station is used to calculate the runtime, eliminating the need to go back and adjust each station manually. If we wanted to apply 14/100ths of an inch, the formula on top would automatically generate a runtime based on the precipitation rate for each station. This runtime is automatically balanced to ensure that an even blanket of water is applied to the entire program. SitePro's ability to automatically balance the application of water through the use of ET can potentially be a large benefit to you by reducing the need to manually adjust individual stations. This feature can also provide you with a beneficial tool in managing your available water resource. For more information about setting up Demand ET and choosing it as a tool for generating runtimes on programs, please be sure to view the companion Training in 10 module entitled How to Irrigate Using ET in SitePro. There you have it. You've just spent another 10 minutes with Toro NSN's Training in 10. This episode has been how runtimes are created using ET. We hope that this helped you understand this valuable tool in SitePro, and that it helps further enhance your career working with the #1 Irrigation Central Control product available, Toro SitePro. Be sure to keep looking for future installments of NSN's Training in 10, the self-paced training module that allows you to get trained and to get going. If you have any questions about this or about future training topics, or if you would like to participate in one of our acclaimed Toro SitePro regional training classes, please contact us by calling toll-free 888-676-8676, option 2. Once again, that's 888-676-8676, option 2. Toro and Toro's National Support Network. Count on it.